Welcome, I'm Bill Wake. We're here working on a programming language called Tenth, and we're implementing it in assembler language using the threaded interpreter technique. We'll see how that goes. Today we're going to focus on the unit testing framework, but I thought I'd first take a few minutes. I took some time to capture things that we looked at yesterday and find a little documentation on things and that sort of thing. So let's walk through those a little bit just so we know we have the resources. The first is the calling pattern. So the caller side does BL to some address, and BL is branch linked. So it sets the link register, which I think is X30, to the next statement following the BL, and then branches to the address that BL mentions. And then on the called side, the first thing you do is you store, and you at least need to store the LR so that if you return, you don't mess up the one, that value is set to return to the next statement. If in your code you make a call to BL somewhere else, that overwrites the LR. So that's why you have it stacked. And you make sure that before you return, you restore the LR. Now, if you're doing a leaf method, you don't need to do the store and load because they won't mess up that register unless you go out of your way to do so. All right, another thing we mentioned was the calling standard registers X0 through 7 are arguments in. You put your result in X0. X8 is a pointer to a block of more arguments. The caller saves those. 9 through 15 are temp registers the callee can use. 16 through 18 are reserved for the system, sort of. 19 through 28 are ones that the caller gets to keep, and the callee can use them if they save and restore. X29 is the frame pointer, which gets us back on the stack. I think it's used basically because the stack will change size while you're doing things. I think it's used to give you a consistent starting point for the current, start of the current stack. We probably won't be needing it. And then X30, there's that link register, and the callee has to save it, which we were not doing yesterday. I found a couple interesting explanations. One was around macros. We found a link for that. And then I found a more general list of assembler directives. I put that a little out of order here, but also LLDB is the debugger, and we tried using it. We used it a little tiny bit. It didn't really identify what we were doing quite. It did show us where it was. We just didn't know how to interpret it, I guess. But a few commands for that. Another, we haven't touched this one, but I did look it up, so I thought I'd keep it. It's the notion of addressing modes. So there are, there's 2 pages worth. The first one is just a simple value, and you can write it in several ways. The next one is register indirect. So you're taking something that's at the contents of wherever that register points to. You can also add a fixed value to it. You can also take one register and add the other and then get the address from that, like maybe for an array access or something, you'd want to do that. Excuse me. You can also do a register access with a shift. So #in basically shifts that second register left, kind of multiplying it by some power of 2. So again, for if you were doing arrays and you had arrays of things that were 8 bytes, you could do LSL3, and that would automatically shift that index by that size rather than having to multiply as you might if it's not a power of 2. Another one is just label, and that just using a label name references the address contained there. Excuse me, there's something called pseudo load. I'm not sure what the point is, but if you put equals there and equals a label, you get the address of the label, equals a number, you get the literal. And then finally, a couple indexing modes, basically pre-indexed. I almost could reverse this. You're gonna return. It's like you index or you increment RA by NN, and then get the address pointed to by that. And the other side is post-index. So this is like C's, plus plus X, increments it and then gives it to you. And this one's the post-index. It's it's get the access and then increment things after you've already given it. And notice this one, the number is outside. This one, it's inside, and there's an exclamation point to remind you. I don't know why. It's a little one-off syntax, I guess. All right, next, assembler directives. I'll move this page up. I just went through that page and just pulled out any ones that looked like they had some use to us, maybe. So, I think there was a quad one. Maybe we might need that. A line we've used, ASCII, ASCII-Z. You can put byte in. COM creates a common area like Fortran might. Data is you do have sections, so you basically can put stuff in the text section, which is kind of where the code goes, or the data section, or you can mix them up. It just depends how you're using it. But like it'd be reasonable to put our constants in the data section. You have an if-else indif. You can equate a symbol to an expression. You can do ERR, which just basically makes a syntax error there. You can fill, I think this is also called space or something. But this lets you create an empty area of a given size, and you can optionally put the value in. The sections, there's one called, normally the way the linker arranges things is put all your text sections together first, then all your data sections, and then the fill goes into something called BSS, and I forget the real translation, but it's like blank storage space. It's space you're allocating, but you're not filling. Now, if you use this value, I'm not sure that's quite true, but anyway, you have these ways of doing it. Float creates more space. It's kind of like ASCII, except for floats. Global, I think this is accessing another objects files variable. Ifdef is a variant on if. lcom lets you create a common area for within your file. You can create sections with names. And I think I had to check, but I think you can somehow, I think there's a way to say like text section number 1 and number 2 and so on. And that would let you kind of segregate things. Okay, string and then text we talked about. So all potentially useful. Then I also caught the LD, the parameters that you might send to the linker. So entry gives the entry point. Incremental links it, but doesn't need to fully do it. It builds a file you can keep linking with. larchive, if you say like -l IB, then you get libc.a or libc, you get libc.a. M prints a map. O tells where to put the output. Relocatable says you want to do partial linking. I don't think I understand incremental versus partial, maybe. Undefined symbol, you can, get rid of a symbol somebody defined. Discard all local symbols and then discard locals. And so a convention that assemblers often have is if you start an address with L, that means it's local only. And, you don't need to pass this symbol around to other object files or anything. There's no point keeping track of all of them. So discard locals lets you get rid of those, not bother including them. And then cref also prints a table. I'm not sure the difference between map and table, but might be something we have to find out sometime. Whoops. All right. Okay. lrbit is strange to me. Yeah. So, this is kind of a RISC thing, although it's, I think like maybe the 360 had some stuff like this, the IBM 360. But yeah, so they have kind of a philosophy. It's kind of a pay what you have to kind of thing. So rather than saying, oh, everybody has to have a stack entry and everybody has to do this and that, the stack is in memory and memory is expensive to get to. So the RISC people often do stuff like this to, just like do it in a register. And if somebody really wants to load the register and put stuff in the stack, they can do it. But the people who don't have to, So yeah, well, like you, I was more used to the stack of being there for you. And no, it's not. You have to stack it. Like, okay, all right. Let's see. I think what did I call this? Is unit testing framework. Okay. I've been pondering this one, and I think we can do some cool stuff. I think we have enough to do it. So the simple X unit. Well, what I have in mind. Well, I'm thinking. I'm recalling. I think C++, maybe. I'm not sure who still does, but there are test frameworks out there that use macros, and I'm thinking like, what if we had a start test, end test, or something like that, test start, test end, something macro, and you wrap your test code in that, and that would give it a chance to manipulate these things, and maybe put the text, like the function name, in a string so we can get to it, and to print the message and so on. So I'm proposing we do that. I don't know. I'm testing the testing of the testing is getting a little backed up for me, but all right. So I think this is useful as a little one-off. I don't know. I don't know how you include. Now, somewhere I read. Let's see. Something mentioned. Include. Well, let's take this. I think if we follow this guy, we'll find the. He mentioned this. Yeah, this thing. So this is the guy that took Smith's book and rewrote it so it would compile on Mac. All right. So, okay, good to know. The book uses that. Dingo is that. Okay. AS minus Q. Yeah. Okay. Darwin. Oh. Subject to change. Oh my goodness, guys. Okay. Yeah, he's got a lot of stuff in there. All right. Oh, okay. I'm just going to look for include if he's going to put it all in one big file for me. I think we're wrapping. Okay. Let's see what GNU does. Include file. Yeah, AS does not invoke the preprocessor. We'll run the C preprocessor. Oh, there's an include directory. Okay, that's good to know. All right, let's see if we can do that. I'm gonna start. I don't know. We're gonna organize things as we go here. Whoops. We'll make a new file, and I think this is going to be. Whoops. I think it's going to be like Unix functions. Dot. Did they say capital S or something? Let's just say Let's do that. If we run across a better description, we'll get there. All right. This, I'm going to put this in here. I'm going to prefix it Unix exit. Okay. And then I want to include that. Well, that's fine. Dot include Unix functions.s. Now, I didn't see include on my list of wonderful things. All right, let's cut this. We got the code in the other file, so. And then let's find exit. Okay. That's different. There's our exit. Unix exit. That's kind of a poor name. All right. Let's go. I hope those don't get done. All right. And we'll do make. Let's see, make sure I'm where I think I am. Yes. Make unit test demo out. Oh. Did you do the include? Well, let's try something in here. Error. Theoretically, that should mess it up. Oh, we got to edit our make file. Yeah, that's sort of our generic, but in our case, unit test demo.o depends on unit test demo.s and Unix functions.s. I think that'll do it. Whoops, cancel that. Error encountered. Okay, so it's including the file. That's progress. Why isn't it using it? Did I make up the contents? Unix exit. Did I call it exit Unix or something? Unix underscore exit. That looks pretty good. Well, let's go back the other way. Let's pull this in. Ah. It's not doing a real include. Well, let's run this just to make sure. Whoops. Well, let's try it this way. Oh. Does he still have error? He does. So he did not include. Supporting files. Code is assembled as if it followed the point of the include. When the end is reached, assembly continues. You control the search paths with -I. Quotation marks are required. Well, we've done that. Let's go up here. So theoretically, dot include quote Unix function dot s. Well, this is going to make it hard. Include. Okay, there it is. Yeah. It includes file verbatim. Well, let's try that. Inc bin. No, it's complaining about line 30. So yeah, when it had the error, it complained about the error when it saw it. So that's why I think the pound include didn't see it. But let's see if this inc bin. Nope. Wow. Well, that is disappointing. Well, okay, LLVM has no equipment. LLVM link, okay. Take several bitcode files, links them into one bitcode file. What's a bitcode file? Okay, so theoretically I can take and just say those. Add the password file to the link or its symbols. I just wonder if it's not, will it do macro, will it bring in the macros? I suppose we could catenate it ourselves. All right, let's take a swat at that. So let's see, LLVM link, unit test. No, we want to do the macro first. Unix functions .s and unit test demo.s, and let's rest the standard output. Okay, that's cool. And let's take this out. I don't know where I have to get these commands. I mean, also, I can probably just I mean, I theoretically can at least do that. Um, that lets me move forward. It would be nice to know if what. I don't know what bit code is though. Is it like bytecode? LLVM format. Text program LLVM. Yeah, I think this is more like the intermediate code for LLVM. All right. Well, I think I can make a makefile that does this. Well, I'm going to have to give it dollar less than to dollar at dot intermediate, and then dot intermediate to dot O from dot O. No, other way around. From intermediate I don't know, a little goofy. Well, that's AS minus O. I think this is int. Well, depending on int is dollar at from dollar less than. Let's do man make. There's a way to tell it to run without doing anything. Is it? No. N. Just print. Okay. Make minus n. Unit test demo. Out. Okay, so where's my cat? I think I've assembled this from S. Load that. Okay. I think I've got to take this out. Okay. Right, that will catch. I guess we don't need .int. Okay, cat those two together. Whoops, I didn't pull enough. Was I'll make dollar arrow. Nope. Cat the files, cat all files to the output, the intermediate file. Build that from that. $add, $arrow. Okay, I think, oops. Cat the two, cat everything, yes. Assemble the object file, build the linker. Okay, let's try it. Yeah. I mean, it used to be all the single character ones. Then they started doing the dash dash nice words because they had more than 26 options on stuff. I don't know why they have 3 versions, you know. I know I've used dry run before, but I didn't know about the other 2. All right, let's see if this actually makes. Okay, we got our error. That's good. Let's see if we get our macro this way. Now the bad thing is, okay, I think we can. All right, nothing complained, and it exited. I think. Okay. Another trick. I think we can say ln1 is sort of saying make the line number be 1 at this point. Oh, and there's a file one too. Where's that? Now I need my cheat sheets. This one. Well, put it over here. Okay. Whoops. Find.ln. All right. So this lets you change the line number, make it an effective line number. So we are not going to support this. Oh, it's only use the synonym ln. Oh, right. Okay. I think ln is what you're supposed to use maybe now. I don't know. They had a note at the bottom too. Yeah, so the line is deprecated. They didn't say ln was deprecated, so I don't know. It seemed like line is a little more expressive. But then I think there's a file one too. Well, we may try it. Whoops, that was whoosh. I just got rid of my chat session. Okay. And closed all the stuff I was looking at before we started today. Okay, Twitch. All right. Okay, so let's start here. So this way, if there's an error in this file, it's going to report it by the real line number. So let's make an error. Exit S and make sure it reports it on line 30. Line 36. Oh, it doesn't like ln. Haha. Okay, we'll try line. Oh, it's so weird that it doesn't, because that's kind of one of these tricks for pre-processing languages, that you let them tell the line, the effective line in the effective file. So if you have an input format in one language and you're translating it, you can say, oh, in the original file, this was file such and such, line such and such, and then the error messages can go report against that. However, we may be finding out that we just don't have it. Hey, there it is. Except it still says line 36, so it ignored it. Okay, fine. We'll get by. All right. Okay, so I think I'm pulling this outside. I think it's awkward. I wish I had include, but pound include doesn't work, and point include doesn't seem to include macros, so we're kind of hurting there. All right, but I think we can move on. Okay, so my idea was we would have macro. I'm going to use test start uppercase. I want it to take a test name and I don't know what else. That'll get us started. Okay, and then I should say I have two tricks up my sleeve on this one. One is we can generate the test. So, well, the first thing is let's use test name : all right, and slash, right, pound slash. Oh no, just slash, I think. Okay. And a macro test end. Okay, I'm going to kind of adopt two lines between these things. Okay, so test name, we're going to say put the test name, which is great. All right. And then what else is going to happen? Well, let's take our test. So we could probably copy that in just to make sure everything's happy. Test. We got the test name. This is, well, we can do that. We can make the prologue. Okay, so test name, do the prologue. All right, and then the epilogue at the end. Okay. And now let's try it. So let's do test start, test 2, test end, And we'll just take the same stuff. Oops. Okay, so let's indent these. Move. Whoops, I guess I want to paste that a little higher. And let's do 2 plus 1 equals 4. And then indent this. All right. So I'm going to make my entry point test 2. Or maybe we'll do both. Okay. Oh, that's an idea. Put the source files in 4. Yeah, let me, I'll just put that in our to-dos. As we go in improving this thing. Let's see, this is down here. Okay. Oh. Get that. All right. Well, I think what we're really doing is write test start and test end macros. Okay. That can go this. Okay. So this should build and run. I know I can't really tell if it's, ooh, failed. What did I change in test 2? Oh, I call it 2 methods I need to do. My prologue here. I think. Yeah, they're going to destroy that. Oh, maybe it doesn't matter with Unix exit. Okay. Test 2. 2 plus 5 equals 7. No. 2 plus 1 equals, 3. Okay, I guess we are proving it runs. If this passes. All right. Yeah, we have computers for this. Okay. I did a new macro or a little shell script to just commit everything that we're up to. And I think we want to say pulled out Unix functions.s as the macros, or macros and initial test framework. Okay, so this runs a status and then no changes to commit. Okay, and yeah, doesn't an add, commit, and push. All right. So I think that's sort of a start of these things. Now, the thing that I wanted to get fancy with, I mean, even just that is something. But I think what we can do, I think, well, maybe this is not worth the trouble, but what I want to do is have a like test, like all tests start or something on the outside, and then find a way to let it discover the tests. I don't know. That sounds like I don't know. Well, my thought was okay. One thing is, yeah. So one thing is, I want to do data and then ASCII Z quote test name. And then back to text. So we're going to work in the text. Okay. So I'm going to sort of default us to text, and we're going to put the code up in text, and then we're going to throw the data down there in file names. And I'm going to give it a label too. Let's use this local label convention, L test start slash at. How can I keep that around? So thing one I wanted to do was get this capture this string so we can put it in an error message. And well, I guess it's all right. Okay, let's do this. Bang test name. Okay, so now somebody can know L test start test name is found there. Okay, I think this is something. All right, now. I don't know if I'm making this too complicated. But what I'm thinking is move x2 gets LTS test 1. And then same thing in test 2. Okay. And then okay. All right. So let's see what we got so far. Okay, we got the prefix. Okay, we put in the test. We're going to put the label. We're going to do the push. We're going to put the test name out there in the data section. Go back to the text section. Test end. You're going to do the pop and the return. Okay. And that's yeah, assert needs to be a macro. Well, I don't know that it does. It might, because we won't know in the body here, we won't know the name of this test. But you're right. Maybe it could. You'd just pass test 2 in. But I think that's sort of, like many X units, they take an optional final argument that's a string name and, use that. Yeah, I wish I could get that name in, like if I had a little compile time stack or something, I could push it on, that'd be handy. But I think this will, well, let's see if we can make this work first. All right. So right now, nothing should change. The Well, LTS test one not defined. Really? And I looked around and I just could not find something that would dump like the text after it did the macro substitutions, which would be really handy. Why is that not defined? LTS test one. Was 112. Okay, so that is blowing up. I don't know if it's just dying at the first wrong statement, I guess. Oh no, it's not. It is legit. Okay. I didn't put that one in the macro. Test start here. Test start test one. Don't need to do this now. That's defined, and this is test end. Unknown fix-up kind. Is it because it's in the data segment? Unknown fix-up kind. Let's try it. I'm going to say branch to label TS exit test name. Take out the text and data stuff. This is more experimental than. Oh, this should probably be at. No one needs to reference it outside this macro. Okay, so exit no op. I guess my labels are in the first column. Okay, so this will be label 0 the first time. Jump over this. My theory is there some issue with accessing a different segment, and we'll just stick the string in the code and then let it jump around if that's really the issue. Well, did I mean not one? I probably did. Yes. I haven't settled on case either. Fix up not sufficient. Ooh, right. And now we're just down to unknown ARC64 fix up kind. I mean, the labels are looking all right. No. He seems to get define. I don't know. The RDR instructions. Or a different section. It can't encode the offset. Doesn't know how the linker will lay it out. Okay. Oh. Yeah, I knew it had to be close. Ugh. ARX symbol on page. Yeah, that's... Yeah, let's read the clang source to understand our assembler. Okay, so... Well, this has to be aligned to here, but the end of it may not be. All right, I don't know if I tested this or not. It's... No. Well, that didn't help a whole lot. Yeah, thank you. No. No. Oh, well, this may be... okay. I don't know. Unknown fix-up kind. Move X2. Now, I'm also puzzled how this is line 67, because this is only 7 lines. Oh, maybe that's after macro expansion. Move X2. Okay. I think that one's maybe not relevant. Okay, text test name. We're getting the alignment right. when we print, and we got our messages, ADR. Oh, maybe I have to load it first. Yeah. Address of pages at a 4. No. PC relative. Yeah, he's got to find it within a megabyte. We don't have to worry about pages. Well, ADR is the PC relative stuff. I mean, I guess that's a good thing. I think it's supposed to calculate this itself. Okay, let's see if we can get rid of the one error like that. So the assembler, the assembler does do some substitutions and stuff like that. So I think that's what's going on here. That it just doesn't like a move, because if it uses ADR, it's relocatable code, because wherever we move this stuff, it's going to be relative to the PC at this point. So the assembler will say, oh, LTS test 1, that's defined up here at, position 40, and I'm on 61, so it's minus 21 to me. And if you end up sticking stuff above it, regardless of where it puts it in memory, that relationship holds because it's all in one module. All right. But I'm not intuitive enough about, I don't have anything that tells me all that stuff. I mean, I really have not been able to find a Mac assembler manual. I did look around. I mean, and this is really, I don't know. It's really bad on their part. It's like, how are you supposed to do this stuff? We're taking GNU, and where it blows up, we try, other stuff. As opposed to just documenting, like, here's what we do for these, line is not supported, this is, not supported but ignored, all that stuff. I mean, that's just kind of basic, documentation for system stuff. All right. And run. Have you recently? Not really. Okay. Well, I guess they don't want you to use the assembler, which is fine, but like, it is available. You're providing it. You could document it for us. But yeah, I mean, I don't know. Gosh. I want that manual somewhere. And even if it were just a big documentation to say, like, oh, we're like a new assembler, but, LN not supported. This is done this way. We patch up things like this. Okay. But anyway, what we've done is we've changed our move. Well, we used ADR down there too, huh? Move to ADR, so it didn't know how to patch up directly on a move, but it knows it for an add relative or address relative. Okay. But I feel like this is good. Now, I think, let me put this back in the data section. I think it's going to break. I don't think it likes doing labels across. Oh, no. Whoops. Oh, it doesn't mind. Okay. Yeah, now we're cooking. Okay. And this is probably not needed, but it's harmless. Okay. So, yeah, so we're producing two things. One is, well, we're putting in the prologue. Whoops. I keep looking in the wrong place. Oh, jeez. Let's try this here. Data. Text. Okay. And then if that works, we can get rid of the branch. It doesn't like going outside its segment. Okay. Right. So what I was hoping to do was stick those strings in an external, a separate segment, and then to get the test names. Somehow I want to get those names to the runner, and I'm going to give up on that. JUnit didn't have it for at least a while. I think a couple of years. You had to just list out the tests, and you would forget you added a test, and it wouldn't run, and you'd be like, "Why didn't my test fail?" All right. So we do label, status, or push. We skip over the string. And put the string in there too, so we can reference that. Handy enough for the brand, the assert. Spit out. All right. So I don't think the all test thing. What I was going to try and do was write this test name address to another segment. See, the thing with segments is they let you accumulate stuff, separately. So I was going to try and put this in a special data segment to have the label for test, for test name, test 1, test 2, test 3, get all their labels, put a 0 at the end, and then write a loop that would say, get this address and branch to it, just like we do when we start here. So it would have built in a little loop that walked through that table of addresses and did it. Okay. Instead, we had to write BL test 1, BL test 2 like a savage, but that's okay. All right. This probably doesn't matter, but that's okay. Protected. All right. Now let's make this. Let's pull this out too. Okay, and then I'm going to make a new file. I guess I'll call it asUnit. And this has these macros. Okay. And then the make file needs to do asUnit.s. Okay. And that. All right. Make. Oh, I didn't change my make file. Oh, wait. Yeah. What happened there? Okay, unit functions. Where's my AS test? Make sure I saved everything. Oh, like the make file? No. Oh, it didn't do the cat. If I change this, the intermediate file should be out of date. Am I backwards on my make macros? Dollar less than, dollar arrow is the full list. Okay. Dollar at is the target. Less than is dependency 1. Well, that should probably be the arrow. That should go. Okay. I'm not sure why it's not rerunning the cat. Let's touch unit test demo.s and make. There it goes. Okay, and that worked. All right. I'm missing something in the make file though that it didn't pick up. I guess. All right. Let's look at this make file again. Oh, clean. I'm going to remove out, and I'm going to remove the ints. That's not the problem we just had, but they should go away. Why did you not work? I changed unit test demo. I changed asUnit. I don't know. All right, this time it should say it's fine. Okay. All right. So we're getting closer to writing real tests. Okay. So now assert equal. The question is, do I require it? Okay. I think what I need is a print. I think the time has come to handle the zero terminated stuff. Okay, so we have our messages. We did them ASCII Z, so we could just pass that string to a print method and not have to pass the length. Okay, now, as usual here, like I have no idea how to do byte arithmetic on this thing. Okay, we've got an address. We got the address of the string. Yeah, I guess I'm gonna have to I might have to, I don't know, do we use a little tiny register or something? Well, maybe this guy did an example. You used two uppers, so I know he's doing this. Is this? Nope. Well, that's definitely too far back. Let's try chapter 4. Not sure what this is doing. Assembly of a case statement. Okay. Print word. STRB. Let's see what that's about. Hopefully that's like store byte. Okay. Wouldn't it be nice if you told me the opposite? I don't know. Is it 80 RB? No. Um, I'm not sure what he was doing. Parameter still has address the byte we're writing. Okay, so he's printing something in hex. I don't know why this would be bytes. Okay. Oh, so that's the digits that he's going to use as output. I really just want to write like a count. strlen, I guess, right in C. Subs. Okay. Let's go back. Well, let me bring this book up. Yeah, if you have the start and end address, it's easy. We could probably do something like that, but I don't want to. I'd, I'd just like to let us create ASCII-Zs and do the right thing with a little count. I think is doable. Let me see if I can. Let's go to the table of contents. I guess I'm kind of being cautious on his behalf, but let's try chapter 5. Yeah. Okay, so he's converting a string to uppercase. He's got the address. Okay, so ADRP. Oh, is the page. Okay, he wants to be able to grab it anywhere. I don't think we'll have to do that. Oh, a load byte. Okay. Yeah, I think this we can do. All right, here we go. Let's TDD up a string length. Empty string length 0 and test end. And I guess I'm going to start putting these closer to their ends. Okay. So if you well, I'm going to branch. No, I can do it. Oh, no, I can't. Let's branch to after data. And then L after data. And then that's our code. And in here, ASCII Z, empty string. Okay. So we're going to load that string. I guess we're going to load that address. We can use x0 L after data. Okay, so we got the location in x0. We're going to call I don't know if I want to call it C, but let's call it string len. No, maybe strlen is okay. Okay, and then when we get back, we expect we expect x0 to be the count. X1 is the expected value, is a 0. And then the address x2 is LTS empty string length 0. Okay, and then branch branch link assert equal. Okay, create an empty string, load the address into X0, run the string length routine. We should get a 0 back as our expected value, and there's the message for the error. Okay. I think this test should fail. Yeah. Not like that. After data colon. Let's do our line. Okay. Test and 1. Yikes. Okay. Golly. Only 3 errors in there. LTS empty string length not defined. Oh, did I type an O instead of a 0? Sure enough. Golly. Okay. Thank you. I've covered up my chat. No wonder I can't get anything. Okay. The ASCII Z. Oh, I don't know if the ASCII Z will do UTF or not. And your other question, was he using a pointer? Address of output string, address of input string. Yeah, he didn't give it a count, so he's doing something. Loop if the character isn't null. Okay, yeah. All right. So our routine we're going to make string length and it's probably a leaf, so we don't have to do any fancy stuff. Just return at the end. Okay. So let's get this. We're going to do a load byte. W5 X4. I forget what W is. Is that the 16-bit, 32-bit? 64 registers. I didn't think we need to know, but I guess if we're going to read other code, it'd be helpful. That's 64-bit ones. Float. No, we had another one that told us those. R0 is generic, X0, W is 32-bit. Okay. I don't see the advantage. Yeah, I really don't. Okay. So, well, the simplest thing we could do is move 0 to X1 to 0. Gets 0. And oops, X0 gets 0. I guess the simplest thing is just do nothing and make it fail, right? So if we don't do anything, it should fail. Oh, what do I got going now? Strlen is... that label looks okay. Now, what the heck? These guys are calling add. There's add. Maybe I could do it in a line, but I shouldn't have to if everything's instructions. String length. Return. Okay. And then run. Failed to fail. Yeah, I don't know why it should matter. But why did this not complain? Let's throw junk in there and get it to fail. X0 gets 42. Assert equal checks X0 versus X1. How about if we call it after I described how many times I've forgotten to do that? Can you fill it in for me? No. Maybe there should be test in front. No, we already said test. I guess it's okay. Okay, and now then I think my original implementation should fail of doing nothing because X0 should have a string address in it. So yeah, I expect that to fail. All right, and this is how I started doing TDD before I had access to IDEs. All right, failed. Good. And now if we make it 0, it should pass. Okay. Well, these tests get so long with this. All right. Well, that's sort of the easy one. I don't think longer tests are going to be any better. Well, how about just has nose length? Okay, and that's 5, 10, 11, 12 characters. I'm beginning to wish for that macro. um, okay, so this becomes different. Okay, so we got hello world. String length should be 12. Okay. Does the x2 string have to start with LTS? Oh, yes, thank you. All right. Okay, so this should fail. And if we put it in, oh, I can forget this all day. What's it called? You really wanted to make sure your study test failed when you're doing this way. Okay. All right, now we got to do some work. Okay, so x0. Okay, well, let's see. I guess we have to load byte. Well, I almost want to do it. Okay, let's go back to this example. We got to do a load byte from address and increment. Okay, so let's move. Let's make x1 equals x0. Okay, so we're going to save the parameter, and we'll let x0 be the counter. Okay, and then we're going to, well, we're going to do a loop. Yeah, we're going to make sure. Okay. Yeah, we're going to do a while. So this is while x contents of x1 is not 0. Okay, so loop. Man, having to choose a different address for each one of these things is ridiculous. But I probably should be writing smaller files. Okay, loop. We're going to load the byte into x2, which is the contents of x1. And if I go to our addressing modes, we had an RA plus RB. Okay. Yeah, I think we can say x0. So this is the address plus the offset we have so far, which is the count we have, which is 0. Okay, that should get us the current byte. And then we're checking, well, if it's nil, compare I don't know if a load byte will set that flag. Okay. Well, compare x2 is the current character to 0. If it's not, no, there's a better way to do this. Sorry. Yeah, let's get this habit going. Input x0 is address of a 0 terminated string. Process, let's say x1 is address of current character, and x2 is value of current character. Output x0 is length of string. Okay. I want to get this post decrement thing going. Register. Right. I should be able to do £1. Okay. So that is grab the register and then increment it. All right. So grab x1's got the string in it. If x2 is 0, branch .eq, probably. X. Oh, it just looks at the flags. Okay. Otherwise, if it's not 0, then we want to we want to increment x1. We want to increment our count. I'm definitely feeling like we can do better. Branch the loop. Okay. So we're zipping that thing through. x2 left address of x1. Like I want to do everything, I guess. I want one thing that will let me access that. This is with a register. Yeah, I want register offset plus auto increment, but you can't do both at the same time. All right, let's see if this works, and then we'll worry about refactoring. Invalid operand. LDRB, this, that, 1. X2, X1. It'll return colon. Okay. Maybe this only does W's? Okay. No, I want documentation. Gotta do it in a W. Interesting. X with post index. Pre-index. Okay. That explains why they use W. All right, so W is the value of the current character. Okay. Invalid operand. Add. I think I could do this. There might be an increment instruction too. Okay. Well, I'm putting the count in x0 because that's the return register. So I'm all right. So I gotta think this one through. Count be x1 minus the original address. Yeah, we could probably do something like that. Okay, x0 starts out 0. Okay, so we load the byte at x1. That gives us a byte. Then we post increment x1. So now x1 is 1 higher. If that byte is 0, then we jump to return. Otherwise, we add 1 to the counter, go back to the top of the loop. And eventually, we should hit a byte that's 0. Okay. Yeah, we could. Well, let's try. I got another experiment. Okay, let's save this. No. Okay. Some versions apparently have a break instruction. Okay, so if I keep the... Yeah, I mean, we could... we could subtract... x1 equals x2 minus x1. Oh, I'm sorry, x0. x0 equals x1 x0 x1. Subtract x1 from x0. No, it's the other way around. Means I may need to count the other way, but okay. Is this better? Oh. Well, load byte x1. Yeah. Yeah, I mean that move x1, x0 equals 0. Then I have to increment manually, right? x1 plus x0. I feel like I want to swap those two. All right. Branch equal. If it compares equal, then we jump to the bottom. Return. Otherwise, we're going to add 1 to x0. Okay, are we thinking this is good? Okay, so x1 is the starting address, x0 is the counter. We load this start plus index, compare that word. If it's equal, we're hit a 0 return, and x0 has the count. Otherwise, increment x0 and branch back to the top and load the next byte and continue. I mean, that looks good to me too. All right. Well, I don't know if there's a way to set a breakpoint. Sims site immediate. Okay. Oh, there's a new mode. I mean, this sort of implies you can't use a second register, a third register. Load RWW2 X1 X0. Okay. Let's see if we can figure out how to set a breakpoint. It's probably worth learning to use the debugger. Break. Well, BRKA. Isn't there just a plain old break now? Break after before, propagate break, break after first, setting condition. It's funny to think of these as being RISC machines, but they got 800 assembly codes. Well, break A dot B. PD dot B PG slash source scalable predicate register. I don't know. Doesn't sound like it's break. It's the last active element. I guess that's the encoding. Name of the second source and destination skill reference. Oh, gosh. I think that has changed with 64. I think it does define. Yeah. BKPT. Okay. Unconditional. Okay, well, let's see if... Boy, an example would be so good. Must be unconditional. Okay, let's just try it in there. BKPT. Okay. What was that? B. Hopefully it got through my... Frequency bar kernel parameter configuration. Ugh. Okay, well, which sort of implies it might not even work. Hardware. The ARM documentation, I have not found that helpful. Okay. Well, all right. So unfortunately our print, we have a print macro still, print message. I don't want to call that if I can help it. All right. We're really late for a break. Let's take a break. We'll come back and see what we can do with this thing. 3 or 4 minutes. Okay, welcome back. Yeah, let's use the immediate index. I'm surprised it's not complaining, but let's try it that way and see what we got. So now we got the count. I think they did X1 pound 1, right? Okay, so compare this to 0. Otherwise, add 1 to x0. x0 starts 0. Do the auto increment. x1 changes every time it comes through, but it's hopefully stopped. Let's make sure this BEQ is the right thing. Hopefully it tests for 0 on. We don't want thumb. What does this guy use? Any. All right, so load this X for immediate. Compare it to Z. If it's greater than, go to continue. Compare it to A. If it's less than, go to continue. Otherwise, transform it. Compare W5 to 0. Branch not equal. Loop. I mean, our logic's the same. We flipped logic, I guess you'd say. I just want to make sure it's spelled the same. Yeah, that's not ARM64. Try it this way. B.eq, branch to label if equal. So we're comparing to 0. If it's equal, go to return. Do we choose the byte? Yeah, x0 contains the length, and we start at 0 and we increase it every time. So this is kind of a while loop. We've got, well, yeah, we load the, we got W2, while W2 not equals 0. If it is equal, we return. While it's not, we increment, and then increment the count and go back around. I don't know if we've run this variant, but I feel like we have. failed. Okay. And x0 should be the length. Let's make sure our test is good. Okay, load up pointer to the data in x0. Move to string length, compare it to 12. HELLO, WORLD, those are both 5, 6, and 6 are 12. Okay. Maybe our focus is going to become printing. Printing numbers or something. I was hoping we could kick off the debugger. Maybe we still can. LLDB unit test demo.out. Okay, so if I do next instruction, well, if I run, oh, I can break. Can I do it on a label? That would sure be nice. I theoretically can. I don't think that data is going to be in there, but let's try it. Ooh. Okay. Now I run. Sure. Okay, breakpoint. Load R. Q is quad. I don't know why I interpret some as X's and some as Q's. Okay, so, and I don't know where this is. And x1, x0 with, that's -2. Load Q2 with contents of x1. Add relative x3, this. LLD unnamed symbol. Yeah, we probably can do something to get stuff in the symbol table, but I don't know. I guess I'm gonna run. No. Continue. Hopefully the next one's better. It said it found 2. And x1, x2. I don't know if it's really getting the right string length. I wonder. Oh, good question. Okay. Should x0 start with L after data hello? Yes. Oh, golly. Yes, good catch. I guess it can be this. No. So we're pointing it at a bunch of code. All right, so it's the test that wasn't passing the right thing, we hope. Okay. There you go. Good catch. Okay. Which means this one is not any better. All right. This should be L empty string. And this should use L empty string. I guess the fail, it was passing some random thing. Well, it wasn't random, it was this. And then we just returned 0 for anything, and now we're doing the fancy case. Senko Moon, hello, welcome. We are doing some assembly language programming. We're on our way to implementing a language interpreter, and basically so far we've sort of got a little mini test framework going. And we just got a string length function going. Let's make sure it's still together. Okay, unit test demo, make. We're welcome. Yeah, you can ask advice. I don't know. I don't even get good advice, but you can certainly get advice. All right, let me push this. So we more work on test macros, and we implemented string length. Okay. Okay, and then maybe I should throw that on the bottom of that thing. Let's pull that out. I'm going to make yet another one of these files. We're going to make a cLike. C-ish. cLike.s. You know, I don't think I want to do that. Let's delete that one. Let's try again. cLike. I think I want it to be cLike.lowercase(s). We're going to learn about external values and stuff. Okay, so I'm going to try and move the string length function over to there. And we're not going to mention it here. Okay, so our make file now, %o on intermediates. All right. Let's say cLike.o depends on cLike.s. And then that's going to do that. All right. Unit test demo.s. And this depends on all the outs. Okay, I'm going to take hello world out of this. completely. Okay, so %out depends on O. cLike.o we assemble. Okay. Let's run make minus n this time. Okay, so we'll cat those for unit test demo. We'll assemble unit test demo. We didn't assemble cLike. I'm going to kind of put these in order. Oh, I don't need to say all that make stuff. Okay. Unit test demo int comes from these, and we assemble. cLike.o comes from cLike.s. This should depend on object files. Let's do make clean make. Yeah, that's kind of what I was afraid of. My LD unit test demo unit test, it doesn't have cLike in it. Why not? Well, maybe we're going to get specific. Unit test demo.out depends on cLike.o and unit test demo.o. LD cLike.o unit test demo.o. Okay. Wow, I didn't know Perl was still a big thing. Python certainly is. All right, at least now I'm getting the things in there. So the problem is our cLike does not export string length. Okay, so let's see what we got to do there. GNU assembler export. Is it global? Oh no, it's just export. Global. Hey. Okay. /unit test demo. All right. Oh, good. Cool. Yeah, I thought all that stuff had kind of gone to Python. Okay, so now we're getting there. Yeah, so I think where we are is we've got string length. I don't know if we can pull. Well, let me commit this. Extract a cLike.s with strlen it. Do you have like another major besides computer science? Are you particularly interested in bioinformatics or data analysis or anything like that? Okay, I'm going to make a rule that I'm going to call it .macro instead of .s. What's an asUnit? Okay, there's our test start, test end. Make file. So S is going to go to macro. Maybe macros is better. Okay. And then I don't mention them again. Let's make sure this still works. All right. Okay, so this time we rename .s to .macros, adjust makefile. Okay, and then let's wrap this. Okay, so we wrote macros. We use TDD to create a strlen function. Moved strlen to cLike.s. We moved moved test macros to asUnit.macros. I think that's pretty close. All right, so like this one's feeling like a direction here. That seems all right. And I hope I don't have to look at it again. X0 is the input, X0 is the output. Okay. The unit test demo, it's kind of all over the place. It's still got a print, and we're gonna have to make something out of that. But what I want to do is make it print and calculate the length on its own. I don't know that it needs to be a macro. I think it could be a function. So yeah, we'll make that a to do. I think I would say we've written a simple X unit at this point. That's kind of this. Okay. And this probably goes up there. Okay. So we want to make a print function, make a cLike print function. Maybe, well, takes an ASCII Z string, zero terminated string. Okay, and then I want to improve test framework to show test name and pass or fail. Okay. That's the out file. Yes, we'll do that. That's make a script to run make and out. Yeah, we probably could just, I probably could, let me break something quickly. Well, we know BRK is no good. Okay, so I think I could do this, make /unit test demo.out. He had no complaints now with BRK. What's the difference? Oh, that's in the macro. Yeah. Okay, so he didn't try to run. We'll at least have that line there. Oh, I don't want the semicolon. I want make and. So it only runs the second if the first succeeds. Okay. But yeah, we've got to tighten this loop up. And maybe I'll take another go at seeing if we can get a terminal built in with Atom. It's got console. I don't know. Maybe they missed something. Debugger. No. Get debugger. I don't need that. All right. Well, we made some progress today. I think we've got some decent start on our macros. We got a string length function, which we can use tomorrow to create a print. Well, sort of not exactly a printf, but at least a print. And once we have that, we'll fold that back into the test framework, get better feedback, and then I think that'll let us. We'll be ready to start doing some real tests. You have to hit some startup for the console. Yeah, there's something. I don't know. I will look, but yeah, I don't know. We'll have to. I want this better because I'd really like to just have that in there. Tie it. Hopefully, I can hit a macro and just bang some key combination, Command R or something, and get it to run. But yeah, we'll get there. All right. Well, tomorrow we'll be back 2 to 4:30 Eastern Time, 7 to 9:30 p.m. UTC. We'll work on print. We'll work on the test framework, and we'll see if we can start working on those primaries, those code blocks that just run straight code. And I think we'll once we get that going a little bit, I think we'll knock out a number of those pretty quickly, maybe just knock out a couple and then get our secondaries going. All right. Well, hopefully see you tomorrow or some other time. Take care. Bye-bye.